What's up, everybody? This is Mr. Williams, and today we're talking about simplifying radical expressions. Why do you need to be able to do this? Because when you're dealing with quadratics and the quadratic equation and the quadratic formula, a lot of your solutions will have radicals in them. Now, if you get a perfect square radical, kind of like this one, number 8, we know the answer to that because the square root of 121 is positive and negative 11. We know that, right? But a lot of times you're going to get these other types of radicals that aren't perfect squares. So we got to break them down. Here's how. First, you want to break them down into primes. That means break them down into prime numbers as far as you can where you can't break it down anymore. Then you want to put the pairs on the outside of the radical, singles on the inside, and remember your plus and minus because quadratics have two solutions. So let's just jump right into number 1. 72, square root of 72, we're going to break that down. Now, we just need some factors. Give me two numbers that multiply to 72. Well, you got a few options here, but the first two numbers that come to my mind are 12 times 6. Now, could I have used 24 times 3 or 36 times 2? Yes, you could have used other factors. And if you do it right, you'll get the same answer. The difference is in how much work you do, okay? But you'll get the same answer. And I'll show you a shorter way. So let's break down to 12. Let's break it down to 4 times 3. Again, you could have used 6 times 2. And let's break down to 6 into 2 times 3. Now, I can break down my 4 some more into 2 times 2, right? So now I have broken it down. I've got a 2, 2, 3, 2, 3. Those are all prime numbers. Can't break this thing down anymore. Now we are ready to go to step 2. Put the pairs outside the radical. What radical? The radical of your answer. Now you're ready to put your answer together. Let's get our pairs. We've got a pair of 2's. So because I have a pair, I'm going to put a 2 outside. I'm not going to put two 2's because I'm not counting them individually. I'm counting the group. So one group of 2's, 1, 2. Now, I've also got a pair of 3's right here. A 3 there and a 3 there. It doesn't matter which branch it's on as long as you can pair them together. So we're also going to put the 3 outside here. So that's a 3 and a 2. Now I've got, what do I have left? You may think I have a 4 left. I don't. That 4 has been broken down, so he's irrelevant. The 2 is the only thing that's left. So he's going to go inside because I can't pair him with another 2, so he goes in. What are we going to do outside? Well, let's multiply these numbers. 3 times 2 is 6, radical 2, and do our positive and negative. There's our solution. Why do we need the plus and the minus? Because remember, quadratics have two solutions, and you have a positive 6 radical 2 and negative 6 radical 2. Okay? So there you go. There's our solution. Here's another way of doing it. If you're good with your perfect squares and you know them off the top of your head, you can just do 36 times 2. And we know that the square root of 36, matter of fact, I guess I'll just put my radicals on them. The square root of 36 is positive negative 6, right? We already know that. I don't need to break that down. 6, what's left? The radical 2. Bam. So you'll notice that we got the exact same answer. I just did less work. That's positive and negative. So if you know your perfect squares, go ahead and use them because that's going to get you to your answer faster. But if you're not really that strong with them, just break them down into primes and you will be ready to go. Let's do one more solution. Let's do one more answer. I'm going to try 2 more. I got a couple minutes here. Let's do, I don't know. Let's do 60. Yeah, let's do 60. Break that down. First thing come to mind is 10 times 6. Again, could you use 12 times 5? Yep. It probably will be easy to do actually. So let's break this down into 5 times 2 and break this down into 3 times 2. 5, 2, 3, 2. I'm done. I can't break that down anymore. So now let's start pairing this together. So we've got a 2 here and a 2 there. So that's one group of 2's. So we're going to put 1, 2 here. And 5 and 3. There are no pairs, so we're going to put them both under here. And when there are two numbers, you simplify it by multiplying. And positive, negative. There's our solution. You could have also used 15 times 4, because 4 is a perfect square, and you still get the same answer. All right, so what if you get some funky problem like this? Say you've got a number that's already outside. Say you got 2 radical 200. All right, what do you do on that? Well, you do the exact same thing. Let's just break down this. Let's do this 100 times 2. And I know that this becomes 10 because I know the square root of 100. Can't break that down, so it stays. Now, what about this 2 out here? What you do is you bring it down and you multiply it times any other number that's outside. Right now, we have a 10 that's outside. So we're going to bring that 2 down and multiply it times the 10, and our final solution is going to be 20 radical 2. Remember, plus and minus. It's important that you have that plus and minus because you got to know that quadratics have two solutions. So that's how you do it. So to go over it again, make sure you follow these steps, break them down into primes, put the pairs outside. That's super important. Pairs go outside, singles go inside. And remember your plus and minus because they have two solutions. If there is a number already outside, break down the radical like normal, and whatever number is outside, multiply it by any other number that you put outside. So my math puts a 10 outside. So the 2 that's already there, I'm going to multiply it, and there's my solution. All right, so have fun with these radicals and see you next time.